is Dr. Mears. Today we are going to be doing the summative review for arithmetic and geometric sequence and series. You will notice on the top you have both the arithmetic formulas and the geometric formulas for sequence and series. Let's complete the following problems. Number 1, write down the next 3 terms in each sequence. Some are arithmetic and some are geometric. Be careful. So what I have done is I have provided another page with the examples on it. So these were the examples from number 1. We have A, B, and C. So this is the first example, 3, 8, 13, 18. So let's do these together. So we need to provide the next 3 numbers here, which means we need to find the common difference. In order to find a common difference or a common ratio, because remember some are arithmetic, some are geometric, you have to decide, is there a common number being added, subtracted, or is there a common ratio being multiplied? So first, I'm going to see if I can find a common difference. To find a common difference, let's subtract the second number minus the first. So the common difference here would be adding 5. It is increasing, so adding is the way we go. So 3 plus 5 is 8. Let's see if we keep doing it if we're going to get to the next number. 8 plus 5 is 13. 13 plus 5 is 18. So this is arithmetic in that it has a common difference. So if we just add 5 now, we're going to get to 23, then 28, plus 5 again, then 33. So I just kept adding 5 every time. Okay, let's go part B. Part B, 1, negative 1, 1, negative 1. Let's find the next 3 terms. So first, let's see if there's a common difference. So I'm going to take the second term and subtract it from the first term, and so I get a common difference of negative 2. So, well, that from here to here, so negative 2 meaning minus 2. Well, if we minus 2 from negative 1, we're not going to get to 1, so there is no common difference. Let's see if there's a common ratio. Common ratio, we take the second one, negative 1, and divide it by the first. So the common ratio here would be negative 1. That means that I would multiply by negative 1 every time. Let's see if that one works. So 1 times negative 1 does give us to negative 1. Negative 1 times negative 1 does get us to positive 1. Positive 1 times negative 1 does get us to negative 1. And actually, you can even see, without even doing this, the pattern. 1, negative 1, 1, negative 1, 1, negative 1, 1. So you can even see the pattern. You don't have to necessarily find the common ratio here if you did pick it up automatically. Let's go to part C. Part C, we have to find whether there's a common difference or a common ratio. So first, let's see common difference. We take the second number, 2, and we subtract it from the first. So common difference is adding 1. They are increasing. Okay, so 1 plus 1 is 2. 2 plus 1 is 3. That doesn't work. So it must have a common ratio. So let's for the common ratio. Common ratio, let's divide the first by the second. And so that gives us 2. So let's see, if I multiply 1 times 2, I get to 2. If I multiply 2 times 2, it gets to 4. If I multiply 4 times 2, it gets to 8. So let's just keep multiplying by 2. 8 times 2 is 16, times 2 is 32, times 2 is 64. So again, you just keep multiplying by your common ratio here. Okay, that is number 1. Let's go to number 2. Number 2 says, consider the arithmetic sequence 2, 4, 6, 8, 10. A, common difference. B, general rule. C, 12th term. D, finding the sum. Let's go to our paper where I wrote it out, where I have more space to write. Here is number 2. So here is our 2, 4, 6, 8. We have to find a common difference. So they're telling you that we are going to be adding or subtracting a common number to get from one number to the next. We are increasing here. We're getting bigger. So our common difference, we're going to take this second term, 4, and subtract the first term, 2. So here I'm going to get an adding 2 every time, plus 2, plus 2, plus 2. So let's see if it works. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. So our common difference is 2. There we go. Part B, we need the general rule. Here's the general rule. You also can find that in your formulas on the top of the first page. I just wrote them down. To find the general rule, we're just going to put u sub n equals u sub 1, u sub 1, u sub 2, u sub 3, all the way and so far and so forth. So the first term, which is u sub 1, is 2, plus, we're not looking for an nth term yet, so we don't have an n, and then our common difference was 2. So that is the general form right here. Okay. Part C says find the 12th term. So now we have to use our general form, and where we have the n, we put the 12 in. So we had the n here, we put the 12 in. We had the n here, we put the 12 in. And what we have to do on this side is put it directly into the calculator just like you see it. You can even use parentheses. So 2 plus 12 minus 1 times our common difference of 2, and we're going to get 24. 24. You do need a graphing calculator for this class. If you do not have one or have access to one, you must email me, Schoology message me right away. All right, part D asks you to find the sum of the 12 terms. So here's the sum formula. So sum of the first 12 terms, that's what it asks you to find. Here's the formula. We have to find the 12th. So where you see the n, you substitute the 12 in. So 12, n over 2, 12 over 2. Here's our first term, which is 2. And then u sub n is our 12th term. So we have to actually put in the term that we just found, which is 24. Again, you put that directly into the calculator just like you see it. Sometimes I like to divide this out, but other times you can't divide it out. Sometimes it would be a decimal, so just put it in parentheses like you see it. And then we're going to get 2 plus 24, and our answer is 156. There we go. So that's the sum. So if we took the first 12 all the way across, we went all the way to 12, you're going to be getting 156 if you added them all up. Okay, let's go to the next page. That's sun. Let me try to get away from that sun a little bit. Okay, there we go. Here is your next page, number 3. Find the first term of an arithmetic sequence. The first term of an arithmetic sequence is 3, and the second is 6. We have to find the common difference, general rule, the 5th term, and the sum of the first 5 terms. So we're on number 3 here. So let's go to number 3 on the paper here. Okay. So number 3. Our first term, u sub 1 is 3. Our second term, u sub 2 is 6. I like them to put them in order. The common difference, we just take to find the common difference, the second term minus the first. So our common difference is going to come out to be 3. So I write that in 3. Next, I need to find the general rule. Here's the formula for the general rule. So instead of substituting anything into n yet, because we're not finding an nth term, we just substitute u sub 1, which is 3, not finding an nth term, and common difference, which is 3. And there's your general rule. And I like putting parentheses because it does signify that multiplication part, and I use parentheses just in case if it's a negative. Next, we have to find the 5th term. So we have u sub 5 equals 3 plus 5 minus 1 times 3. So since we had to find the 5th term, we'll replace the n now with 5. In your calculator, you're going to be doing this out, and when you do it out, you're going to be getting 15. So that's the 5th term. Next, we had a part D. I didn't write on here. Let's write it over here. I skipped all the way to 4. I didn't set up part D. All right, here's part D. Part D, we have to find the sum of the first 5 terms, which means we need to use the sum formula. Here's the sum formula. We need to find the sum of the first 5 terms. So in place of n, we're going to put we're going to be putting the 5. So this is going to be 5 divided by 2. U sub 1 is that first term. That first term was 3, plus u sub n, which is our 5th term. And as you can see here, this is our 5th term, so it's going to be plus 15. We're going to put that in the calculator just like you see it. I like to put parentheses around any fraction that I put in. It keeps it together, a nice little hugging your fraction there. And when you do, you get 45. So the sum of the first 5 terms, if you added the first 5 terms up here, if we kept going here to 5 terms and added it up, we would get a sum of 45. Okay, let's go back to number 4. Number 4, Montserrat is training for her first race. In her first training week, she runs 3 kilometers. The second week, she runs 3.5 kilometers. And the third week, she runs 4 kilometers. We have to find her common difference, the number of kilometers that she'll run the 10th week, and then the total number that she'll run by her 10th week, in her 10th week, run after that 10th week. So let's do that. So number 4, here we have our U sub 1, our first term, she ran 3 kilometers. U sub 2 is our second term, 3.5, and then we have the third week, which is U sub 3, which is 4 kilometers. So to find our common difference, we take the second term, 3.5, and we subtract it from the first, which is 3. We're going to find a common difference of 0.5, 0.5. The general rule here, we're going to substitute in our U sub n. We need to find what her total numbers was in the 10th week. So we're going to be substituting 10 into U sub n. U sub 1 was 3 plus 10th week times a common difference of 0.5. Putting that into our calculator, we are going to get 7.5, and don't forget to put kilometers. So in her 10th week, she ran 7.5 kilometers. That's what she ran in her 10th week. Now let's find how many she ran over all the 10 weeks. So we're going to find the total for 10 weeks. This was just in her 10th week she ran. In her 10th week, she ran 7.5 kilometers. Now we're looking for the total. How much did she run in total? So that's what our sum means. So for her sum for 10 weeks is 10 divided by 2 times U sub 1, which was 3, plus our U sub n, which is our 10th week, 7.5. Doing that in our calculator, we're going to get a total of 52.5 kilometers. So the total number of miles that she ran in 10 weeks, total number of miles over 10 weeks is 52.5 kilometers. So in that 10th week, she ran 7.5. Over all of her 10 weeks, she ran 52.5 kilometers. That's pretty good. That's pretty good. Okay, let's go to number 5. Number 5 is consider the arithmetic sequence 5, comma, A, comma, B, comma, 4, sorry, 5A, B, 4. I always say A, B, right? We're so used to saying A, B like in the alphabet. So 5A, 14, B, try to say that 3 times. We got to find the values of A and B, then the common difference, then we have to find the 10th term and the sum of the 10 terms. So let us do that. Here is number 5. So first, let's just find A and B. Let's not overwhelm ourselves. We're just finding A and B. So because A is in between 5 and 14, we need to find the middle of 5 and 14. What is that middle point? In order to find a middle, we need to find basically the average of these. We need to add them up, 5 and 14, and cut it in half. So when we cut it in half, we're finding that middle number, and that's going to be our A. So our middle number, if we do this in the calculator, we're going to be getting 9.5. Yes, 9.5. So now we know that A is 9.5. So this helps us. What did I do here? This is supposed to be B. I'm messing that up. B. Thank you very much for pointing that out. That should be B. Messing this one up, huh? So the middle number between 5 and 14 is 9.5. This will help us to find B. I'm actually going to find my common difference so that I know what I need to add or subtract to get to that next number. Because these numbers are increasing, I know I'm going to be adding by a number. But let's do our little common difference where we take that second number, 9.5, and subtract it from our first number. And so our common difference that we're going to come out here with here is 4.5. So I can use this now. I know now that I'm adding 4.5 every time. And that makes sense. 5 plus 4.5 is 9.5, plus 4.5, 14, plus 4.5 is going to land us to 18.5. So I actually had to find my common difference in the middle of finding A and B. So A is going to be 9.5 and B is going to be 18.5. So just to review that, to find A, I had to add them up and divide by 2 because I wanted to find that middle number. To find B, I wanted to find the common difference, so I knew what to add every time to get to that last number. So I just took that second number, 9.5, and I subtracted it from the first. Now I know what I had to add every time. I did that. I ended up 14 plus 4.5 gives you 18.5. So A and B are 18.5. This kind of just sets us up for our common difference. Our common difference is going to be 4.5. So there was really no, we did that with the problem. Okay, let's go next. What we want to find out is going to be the 10th term. So we need to find the 10th term. So we're going to be using the formula. Where n is going to be 10. U sub 1 is 5 plus 10 minus 1 times our common difference of 4.5. We're going to do that in our nifty calculator, and we're going to be coming out with 45.5. There we go. Okay, next. Can you see that okay? Yep, okay. Okay. Next, we need to find the sum of the first 10 terms. In order to find the sum of the first 10 terms, we need to put the 10 in for n. So 10 divided by 2. U sub 1 is 5 plus U sub n. That's what we just found up here, 45.5. 45.5. Making that a little bit clearer for you, 45.5. We're going to put this all in our calculator, and we're going to come out with 252.5. So if we kept going and counting 10 terms and then added all those terms up, we'd get a sum of those first 10 terms, 252.5. Okay, let's see what we have for number 6. Number 6, it says find the common ratio in the following geometric series. So now we're switching our review over to geometric. So let's do number 6. Here we have number 6 on the paper. 12, 24, 48. That's part A. So in order to find the common ratio, just like the common difference, we're going to take that second number, but now instead of subtracting, we divide it by that first number. So our R is going to come out to be 2. 2, let's just make sure. 12 times 2 is 24, times 2 is 48. That does work. Next, 80, 40, 20. Ooh, we're decreasing, so I bet you it's going to be a fraction. So let's take that second number and divide it by the first. We come out with 1/2 as that fraction. You could also say 0.5. So 0.5 works as well. So 1/2. So every time multiply by 1/2 or divide by 2. 80 divided by 2 is 40, divided by 2 is 20, so that works. And the last one, we have our common ratio, -6, our second term, divided by our first term, and we get -3. So every time we're multiplying by -3, let's see if it works. 2 times -3 is -6, times -3 is +18, times -3 is -54. When you see these back and forth, positive, negative, your common ratio is definitely going to be a negative. So yes, that works. Our ratio is -3. Okay, let's see what we have next. Number 7 and number 8. Number 7, the first term of a geometric sequence is 3 and the second is 12. You have to write down the common ratio, find the fourth term, and then find the sum of the first four terms. Let me just get my paper to see all of this set up. There we go. Okay. So number 7, we have our first term, U sub 1 is 3. Our second term, U sub 2 is 12. They don't give us anything else, but they do tell us it's geometric, which is good. So in order to find the common ratio, we're just going to take that second one, always divide it by the first. We get a common ratio of 4. 3 times 4 is 12. There's nothing else to check. Now what we need to do is we need to find the fourth term. So since we're flipping over to geometric, here's our geometric finding an nth term formula that you can find on the top of that beginning sheet. So we need to find the fourth term equals U sub 1 is 3. Our common ratio is also 4. And I'm afraid the sun is blocking that. Okay. 4 minus 1. Lots of 4s here. So what we're going to do is put all of that in the calculator, and you can do that directly in the calculator. You can do 3 parentheses, 4. Here's your exponent button, which is above the division symbol. And I like to do, you can do 4 minus 1 with little parentheses. If you push the over arrow key, it gets you out of the exponent position. We substitute everything in, and we get 192. Excellent. Okay, what's next? We have got to find the sum of the first 4 terms. So what you could do is you could get the third term, and you could get the 4th term, and then you could add all of these up to get the sum. That's what we're actually doing. However, I'm going to use the formula to get the sum, because sometimes the number is so big you can't find it. So the sum of the 4 terms, here's the geometric series formula to find the sum. We have u sub 1, which is 3, times our common ratio, which is 4 raised to the 4th power minus 1, all divided by r minus 1, which is 4 minus 1. Now you can put this directly into the calculator just like you see it, but be careful. I've reminded you before, you should put parentheses, or you should just subtract 4 minus 1 to get 3. Either way works. So we're just going to do 3 times 4 raised to the 4th power. Don't forget to push your over arrow key, because you need to be out of exponent position. And then minus 1 divided by parentheses 4 minus 1, or you could put 3. And we are going to get 255. So the sum of those first 4 terms is 255, using our geometric formula. Okay, that was number 7. And number 8, in the following geometric sequence, the first term, u sub 1, is 5. The common ratio, r, is 4. We need to find u sub 12. So we're skipping a few steps, and we're just going really right to the problem here. Here's number 5, the first term, the common ratio. We're finding the nth term here. I don't need this paper. Okay. Finding the nth term. So we need to find the 12th. So it said the 12th term we need to find. So n is going to be 12. Our first number is 5. Our common ratio is 4 raised to the 12 minus 1 power. You can simply do that in the calculator. You could subtract this. So you could put 4 to the 11th and then do that in the calculator if you would like to. So u sub 12 is going to be coming out to 20971,520. Boom. And 20,971,520 from your calculator. All right, and let's look at this last problem that we have here, number 9. Number 9, capital of $1,000 is invested in a bank account at a simple interest rate of 3% per annum. That means per year. Per annum is year. Vocabulary, welcome. Part A, we need to complete the table for the amount of money in the bank after n years, assuming no withdrawals. We have a table we need to fill out, and then we need to answer what can you say about the difference, what can you say about the sequence of numbers, and what are the variables. So let's look at this. I actually can just write it on this paper, which is great. No, you know what? Let's do this one. I like this one. So number 9, I said it. I always set up like kind of writing a script. Here we have our interest rate formula. And so let's remember, this is interest. This is going to be our start amount, known as our principal. This is going to be the number of years, and R is going to be our rate in the percent. Okay, so there we go. So now what we have to do is we have to find for each year. So after year 0, how much will he have in the bank? After year 1, how much will he have? After year 2, how much will he have? And after year 3, how much will he have? So these are individual spots. So after year 0, well, that is just his start amount, and that's $1,000. So that's where we're starting from. After the first year, so let's substitute. So year 0, that was just 1,000. That's where we start. Okay, after year 1. So let's substitute our numbers from here. So our interest is going to be how much is in the bank. I did not give myself enough room here. Yes, erasable gel pens are great. Okay, so our interest for year 1 is going to be dependent upon how much we start with times the year times the actual interest rate, which was, on my paper, 3%. So starting with 1,000 and then 3%. So then times 3 over 100. And so we're going to be getting an interest rate of $30. Now that's not how much he has in the bank, because remember, he started with that 1,000. So what we have to do, remember, is take that 1,000 and add the 30. So he'll actually have, after 1 year, $1,030. Okay. Next, n equals 2. So after 2 years, if we just put in the $1,000, after 2 years, how much would he have? So let's find what the interest would be. So 1,000 times 2 times 3 over 100. And so this is actually going to be $60. So now that's not how much he has in the bank. We have to remember to add it with what was originally in there, which was $1,000, and then add the 60. So after 2 years, he would have 1,060. All right. Well, how about after 3? So if he just put it in the bank, left it in there, after 3 years, how much would it have? So then let's do that one. And I'm going to do it down here. N equals 3, little box. So I equals 1,000 times 3 times 3 over 100, because remember, that's the interest rate and that's the years. So I is going to be equal to 90. Remember, that's not how much he has in the bank. That's how much interest he accrued, which means he accumulated. So we actually have 1,090. There we go. Okay, so part B said, find the common difference of the amount in the bank. So let's find the common difference. So what happened every time we went to that next year? We looked if we took it out at 1 year versus if we took it out at 2nd year versus if we took it out that 3rd year. And so what happens is we're adding $30 every time. So that's your common difference, is 30. You could have said, 1,030 minus 1,000, but I hope you can see that we're adding 30 every time. So our common difference is going to be that $30. Our next question was, what can you say about this sequence of numbers? So looking, if we have a common difference, we're going to have an arithmetic sequence. So it is an arithmetic, I already spelled arithmetic sequence, since we have a common difference. And the last question that we're going to be answering, what are the variables? And when you're looking for the variables, you're looking about which 2 things are reliant upon each other. And those are going to be the years and the amount in the bank. So our variables are going to be years, variable, number of years, and amount of money in the bank. There we go. So here's our first variable and here's our second variable. Okay, so this has been simple interest. We finally came to the conclusion that simple interest gives us an arithmetic sequence. We are going to be looking at what geometric sequences, where we go with those, and I'm going to give you a hint. It's called compound interest, but we're going to be investigating that later in our functions and our exponential functions part of the unit coming up. So hopefully this helped, and good luck on that summative.